All right, so purpose of today's lab is we just want to confirm the relationship that is expressed in this formula here that we learned about last week. That the force of friction is dependent on mu, the coefficient of friction, how sticky the two surfaces are, okay, and the normal force. All right, now, there's two kinds of friction, which we talked about last week. There's kinetic friction and there's static friction. Okay, today's lab will be dealing with static friction, okay, because we're going to be pulling on the sled until it moves, and then once it moves, that's it, we're done. Okay, we're just going to measure the maximum force of static friction that is present on each trial. Right? What we're going to be doing, so for the design part here, okay, each trial in this lab, our friction sled will have a different amount of mass in it. Okay, so these are our friction sleds, these blocks of wood. Okay, that's a friction sled. So on our first trial, we're just going to have the friction sled. Okay, gravity is going to pull the sled down into the desk, and what's the desk going to do? It's going to push back. Okay, what force is that? That's the normal force. Now, you're not going to be doing this on a desk because the desks are way too slippery. Okay, you're going to be doing this on the floor. All right, but you're going to have just the sled on the first trial, and then the next trial, you're going to put the two smallest masses in, right, increasing both the mass of the sled and the resulting what force? If I increase the mass, what does the desk have to do now? It has to push harder. Okay, so every trial, I'm going to be adding mass to this sled in order to change this force. Okay, every trial that force will change. Now, also then, every trial, what other force should change? Yeah, this force, I hope. If it doesn't, then this whole formula is full of it. Okay? And classical physics as we know it will break down and there will be chaos, and so this will work. Okay, just so you know, so you don't worry. Okay? This whole thing will work. All right, so that's what we're going to be doing. Okay? We're going to be altering the normal force, measuring the force of friction. The way we'll measure the force of friction is with these force sensors. All right, so we're not using the carts, but the setup on your phone is still the same. All right, you're going to hook up this apparatus. All right, so you're going to have the force sensor, which is this blue thing with the hook on the end of it, and you're going to have a Pasco Air Link. There are 4 white ones. Try and use the white ones. If you don't get up here quick enough to get a white one, then you'll get a blue one, which works pretty much the same. Okay, the white ones we just have more charging cords for than these ones. Okay, so you'll hook up. Now the way this hooks in, you have to be aware because people do this wrong all the time. It's a serial connection. These connections are like before you were born designed. Okay, so it has to go in one way. You can see that the plug has more plastic on one side than the other, so it'll only go in one way. Okay, don't force it. Otherwise you'll bend all the little pins and that thing will be wrecked. Okay, so put it in that way, and then turn it on with the little power button, which is right here on the end, and you'll see the Bluetooth thing starting to blink, and then you can pair it with your phone, same as the cart. Okay, so after that, it's the same as the cart. Now, what you're going to do on each trial is hook the sled to the hook. Okay, make sure that everything is tight and ready. Okay, and then on each trial, you're going to increase your force very, very gently. Okay, don't just jerk it on the first try. Okay, what you want to do is just increase your force ever so gently, and as soon as the sled starts to move, that trial is over. Okay, because we'll have overcome the maximum static friction that condition can produce. Okay, then you'll add mass. All right, so on the next trial, so the first trial, empty. Okay, second trial, the first 2 masses. Third trial, put in the 3rd mass, give it a pull. 4th trial, the 5th mass, give it a pull. Okay, and so on until all the masses are back in the sled. Okay, everybody with me there? All right, so we've talked about manipulating, responding. Okay, here's some other stuff to think about for your controlled variables and the general setup. This experiment I want you to do on the floor. Okay, now my suggestion would be that you take one of the paper towels from over there on the wall, okay, and wipe down the area of the floor that you are going to use. Okay, I would select 6 different tiles, 1 for each of your trials. Give all of those tiles a wipe. Okay, then on each trial, move to a different tile. Okay, they'll all have been cleaned, but you don't want to use the same tile twice. Okay, because if you do, you could be changing the condition. Anything that the sled picks up could end up on the floor, and that could change part of that formula, and we don't want that. So you're going to get a fresh, clean tile for each one of the trials. Okay, and then obviously it's going to be the same cart and all of that kind of stuff. Okay, one other thing you need to be mindful of is that for this lab to work properly, the force sensor also needs to be on the floor. Because we did a problem like this on Friday. If I pull slightly upwards and forwards, does that change the amount of friction? Okay, so I want to make sure then, vector-wise, that this is down on the floor. It's okay if it's a little bit sideways, like if it's a little crooked like this one is, that'll still be fine, as long as there's no upward or downward component. Okay, so just put the force sensor on the floor and give it a pull. Okay. All right, 4-hour hypothesis. Okay, the if part should tell me the relationship between normal force and the force of friction. Okay, so talk about what happens, or what's the relationship here? Is it linear? Is it exponential? Okay, when this one goes up, what happens to this one? Okay, the and part just describes the experiment, which we've gone through already. In the then part, I want you to tell me how you would calculate mu from a graph of normal force versus force of friction, because you are going to build one of those in this lab. So you'll have a graph, okay, that looks like this. Spoiler alert. Your graph will look like this, okay? You'll have a line that goes up like that, okay? Normal force on the x-axis, force of friction on the y-axis, okay? Tell me how you think you would calculate mu from that graph, okay? I know that you could do each trial individually and just do this. Mu equals force of friction over normal force. I get that. I don't want you to do it that way, okay? This, using the graph, is more experimentally valid than to do each trial separately. Okay? Yes. All right. Is that making sense to everybody? Okay. So when we do this lab, okay, this is what you're going to get. Okay, you're going to get your forces. Okay, and in each one of those things, you're going to see the force go up, go up, go up, go up, and then suddenly drop. Okay, you want the biggest number in that column. That will be your force of static friction for that particular trial. Okay, because as we pull, the force of static friction resists until it gets to its maximum, and then the sled starts to move. Now it's not static, but kinetic friction. Okay, so we're looking for the maximum force of static friction, which is why as soon as that cart starts to move, okay, you're going to be, that's the number you're going to get. So you'll just look through all of your numbers in the chart and find the biggest one. The biggest one will be your force of static friction for that trial, okay? And obviously you'll know your normal force for each trial because you're going to calculate it in this chart right here, okay? So you'll have the mass of the sled, okay, in each one of those trials. Mass times 9.81 will fill in the normal force here. Okay, everybody good with that? All right. So, like I said, the collection of data for this lab is really fast. Like you pull the sled 6 times and you're done. Okay, and then you just have to go through your data and find the biggest number. Okay, like we were saying, pick the biggest number. That'll be your force of friction. Then you're making a graph of normal force versus friction force. Okay. All right, for the analysis, oh, there it is. Okay, so for the analysis, okay, all you're doing is filling in this chart and then showing me your graph and how you calculated mu from the graph. I cannot stress enough that it must be from the graph. I do not want to see 6 separate calculations of force of mu going normal, or force of friction over normal force, okay? You must use the graph, okay, here. There's an easy way to get it off the graph. Get the equation, hint, hint, it's in there, okay? Okay, for your data. All right, so you're building a graph just like you have for every other lab, okay? Get it set up, get the equation of the line, all that good stuff. It's only gonna have one line on it. All right, then you'll have your conclusion, copy paste your hypothesis, tell me whether the relationship held up, did you get a linear fit, okay, were you able to calculate mu, right, all of that kind of stuff. Sources of error, okay, talk about that, right, I mean, there's some things that we're doing to try and make sure the conditions are the same for every trial, but they might not be, okay, there's little things in there that we're doing our best to control, but may not totally control. Controlled variables are always the best place to look for a source of error. All right. Questions on that? Okay. Have at it. If you need some help, just ask.